Hello, welcome back to my channel. My name is Marina Ray, and we continue to review the textbook Construction Materials, Methods, and Techniques Building for a Sustainable Future. This video is about chapter 6, and that is foundations. So let's talk a little bit about the learning objectives. So in this chapter, we'll take a look at the factors to be considered when designing foundations. Then also we'll identify a few types of shallow and deep foundation systems. And then we'll discuss the features and construction of common types of foundations. So when we talk about the foundation design, we know that there could be settlement and there can be no settlement, uniform settlement, and differential settlement. And we need to make sure that we analyze the soil and its competence before we design the foundation. So always, as I always recommend in my videos, refer back to the textbook because there are so many graphics sections and other plans and just images that will definitely help you understand the topic. So when we talk about the foundation types, there are a few types. So it can be a spread footing, it can be friction pile, and bearing pile, belt pile, socketed pile, and so on. And that goes to the bedrock. When we talk about the shallow foundation, they consist of a footing. So the basis of the foundation that transmits building loads directly to the soil, and a stem wall, the vertical portion of the foundation that reaches to grade and provides the base for the superstructure. Then when we talk about the spread footing, that's the most common shallow foundation type. Then you can also find independent footings, also known as footers, and also grade beams and other types of shallow foundations. Please refer to the textbook. When we talk about the slab and raft foundations, a slab on grade is a reinforced concrete foundation that is placed directly on the ground to provide the structural support. Then post-tension slabs on grade, they are used to overcome problems associated with unstable soils for ground-supported residential foundations for the most part. Also, you can use another method of dealing with expansive soils on project sites, and you can use the underslab voids that are created by pouring slabs on top of void forms, and that is the carton forms. Please refer to the textbook just to review the images and see actually how that is designed and constructed. Raft or mat foundations are reinforced concrete slabs several feet in thickness that cover the total footprint of a building. And again, refer to the images here. Then we move to the deep foundations, and that actually we need the deep foundation when it becomes impossible to provide a suitable bearing surface for a structure close to the surface of a site. And there could be a few reasons for that. So let's talk about the displacement piles. That is here. You can see it on the plan, and please review everything here because that is important to understand how that is driven to the soil, how the load is distributed, and how much actually they can bear. Also, when we talk about the displacement, please refer to image 617 here. You can see there are commonly used pile materials and types, and that is important to remember because that can be timber, it can be pipe, open-ended and closed-ended, then it can be an H-pile, cast in place concrete, it can be a tapered section steel shell, then precast and pre-stressed concrete, as well as the composite piles. Also, what else we can see here, there are a few methods of drive and displacement piles, and usually it's driven into earth with pile hammers, and there are some other techniques that you can find here in the textbook. Also, when we talk about the non-displacement piles, they are end-bearing units that are constructed using large diameter drilling rigs. Again, please refer to the process here. It's described here because there are a few steps to do that. And there's more information about the continuous flight auger and also other types. When we talk about the geopier foundations, that is a pile foundation system in which stiff rock columns are constructed deep into the ground to a suitable bearing depth. And again, a lot of images. So please make sure that you actually take a look at them because that is important to understand when you do the structural calculations, and always liaise with a structural engineer because they learn the formulas, they know how to deal with that. And if you're dealing with that at the construction site, that is critically important. This collaboration is critically important for the load bearing capacity. Thank you so much for watching. That was it for our chapter 6, and I will see you in chapter 7.